Hello guys, hope you're doing well. My name is Mahmoud Kiasari and welcome to another interesting chapter of electrical circuit. As you guys may know, for the previous chapter we were talking about the fundamental. What is current, what was electrons, how were those valence, shell or atomic, some kind of behavior of each specific atom that is related to each specific material, how the electrons actually are going to move, how we do have the current, and this kind of thing. So at this point, we are going to touch down the very important part of electrical circuits. The very first one is about the circuit itself, how we can have it, what are the different part of the circuits, how we can combine those components side by side each other. What does it mean by each of those components when we do have them? And then we are going to talk about the very important law, the Ohm's law, how we can use it in order to find the things that we would like. So without further ado, let's talk about it. As I just promised, for this one, we are going to talk about the series circuits. I will tell you what is the series circuit, what are the components, and we are going to master the single path for this one. The very first thing that we have to know, what is going to make a circuit series? Or maybe we can have the better question, what is a circuit? The circuit is the combination of a couple of things. The very first thing is your source, that we know as a voltage source. Then we need the path. The path is going to be completed using the wire. In the meantime, we do have something we call as loads. These loads, or something we call it right now as resistors, can be just normal resistors that we are going to use them, or they could be the load like lamp or your heater or anything that could be activated by DC power. Maybe the very first question that you have is that why we do have these components. Obviously we try to move electrons, right? And we also learned from the previous chapter we do have two ways of movements in electrons. One way is one thing that we call it as the conventional way, that you used to use it in some kind of impasse without knowing the fact that actually electrons are moving, not protons. Another way is the normal way, or is the logical way, that it means that my current is going to be from negative to positive. But as I just told you, we are going to use the old school and we assume the current goes from this part, the positive source, to the negative source. Why do we have this source? If you guys remember, I told you when we do have a wire, we do have electrons in each atom. Specifically by talking about electrons in the valence shell of that specific atom. If we do have a copper, that would be something we call it as a conductor, there's a high chance that by giving a little bit of energy, we can move all of those electrons. By moving electrons, we are moving the energy and we can do something with it. We can heat some kind of our heater, we can make it warmer. We can turn on the lamp, we can do everything we like. Everything that is around us is based on that. But here's the real question, how we can have that energy? That energy comes from something we call as a source. And at this point, we do have it as a voltage source. The voltage is energy that I'm going to give to my electrons or give to my atoms in order to getting rid of their electrons. If I know for a fact that the atoms can getting rid of their electrons, I'm going to give them energy. Those electrons can move in a path. Another question is that makes sense if you use a load for your work. But why use resistors? What are resistors at the very beginning? Resistors are components that are going to resist again the movement of current or the movement of electrons. Maybe some of you would ask why we're trying to do that. Obviously, we are going to use the very high capacity of our voltage source, right? It's 12 volts, 24 volt, 20 volt, whatever it is that we're trying to use that. But here's the real thing. Not all the time, the load that you have can handle all of this energy. By energy means that by giving more and more number of voltage or energy, the current is getting higher and higher and higher. But not all of the loads can handle that. In order to control the current inside your loop or inside your path, we are going to resistors. So resistors are the thing that are going to actually fight against this flow of current or flow of electrons, and we can use them based on different kind of materials in resistors we will talk about in future, and especially in the lab itself. We can control this current itself in order to not damage our load itself. So what is the series circuit? Imagine that you do have everything connecting each other in one single path. It means that all of them are connecting to each other. And even if you disconnect or getting rid of one of these components, everything is gone. If you just put out your R2, R3, or if there's any other kind of part in this system, everything is going to be collapsed. Another thing that we know right now is that the current or the flow of electrons is as the same as the one that you have for a voltage source is going to be the same in your R3, R2, and R1. Or in a simple term, we can say the current that comes out from the flow of electrons is going to be the same for both of them. So we learned two facts about the series circuit. Series circuit means that all of the components are going to be in a single path, side by side and sitting beside each other. If you get rid of one of them, if you disconnect one of them by using a switch or just disconnecting one of them, you're going to make as something we call as open circuit, or you're going to collapse the whole thing. There is no flowing of current anymore. And the second thing is that the flowing in current in each component is the same. These are two facts that we know from the circuit or the series circuit itself. Remember those. So then we do have these core principles, we were talking about it, that components are going to be connected end to end or in a series path. There's only one path for the current to flow. As I was just talking about it, the current is going to be same everywhere in this circuit. We don't care. I'm going to measure it because we do have devices that we call as multimeter, or maybe for AC part we do have the oscilloscope, and we are going to see it in the lab. It's going to be cool. You can measure the current here. It doesn't matter. Everywhere the current is the same. If the path is broken, as I just told you, at any point, it doesn't matter. If you break the path here, it doesn't matter. At any point, like a failed component, imagine that your resistor is going to be faulty and this guy is not allowing any current or electron to pass, so it is faulty, it is not working. The failed components, the entire circuit stops working. This is the series circuit's greatest strength, and it's also greatest weakness. So the golden rule of series circuits, let's talk about it. The very first thing, as I just told you, is that the current is constant. Current is something that we show it with I is the symbol in order to show you the current itself. And we do have the way of measuring that. The current or its unit measurements is amperage, or we call it as A. And sometimes, or I can say another common way is milliamp. Because amperage is a very huge number and it's also dangerous. That's why when we're working in lab stuff or in our some kind of working with a very small amount of voltage, we talk about milliamp, okay? Milli means that 10 to the power negative 3 of amp, okay? 1 times smaller than amp itself. So as I just told you, current is constant. It means that the current has the same through, is going to go everywhere in each component. The I total, that most of the time the current that gets out of the voltage source, we call it as IT or I total, is going to be I1. The current goes through the first resistor. The current goes through the second resistor. And the current goes through the third resistor. All of them are going to be the same. Voltages are going to be add up. What does that mean? As I just told you, voltage is the source, is your energy. And this voltage is going to be divided in each of your components. And like energy rule that we have, energy is not going to be destroyed. Energy is going to be converted from one form to another, or at this point is going to be divided between all of your components. It means that if I assume the amount of energy or amount of voltage that I do have in my first component is 4 volts, in the second one is 5 volts, in the third one is 3 volts. If I add all of them, I still should have the same amount of energy as the mother itself, as a source. It means that your E total, sometimes we show the voltage as E or V. The source or the units for that is voltage, that we could use as just this letter of V in order to have that. The E total is going to be V1 plus V2 plus V3 or plus any other components that we have. This is something that we call as KVL or Kirchhoff's voltage law. This is a law. For example, we do have the energy law, we do have Newton law, we do have this guy as a Kirchhoff's voltage law. It's kind of intuitive, by the way. So resistance. What was resistance? As I just told you, resistance is a component that is going to fight against the flow of currents, the flow of electrons. So also resistance, or the amount of resistance that you have, which we call it as a total resistance, by the way. The total resistance in your whole series circuit is the resistance of 1 plus number 2 plus number 3 is going to be R total. What is the unit measurement for resistance? Is ohm. So when we say that we do have 100 ohms, means that I had 20 ohms, I had 30 ohms, and I have 50 ohms, and I'm going to add them up together. Right now, I completely understand it. It could be a little bit confusing because you are learning too many things at a time. First of all, about the currents. Again, we learned the definition, but how we can measure the current is something that we call it as I or amperage. I can give you another way in order to completely understand it. If you remember, we were talking about Q. What was Q? Q was the number of electrons times the kind of the charge that each electron has, 1.6 times to the power negative 19. How I can say, or how I can define the current itself? Current means that the total charge or total Q that I do have that is going to pass through the time. Or I can say I equals Q divided by T. Q was the charge related to electrons, and T is a time. That most of the time we use it as seconds. I is equals Q divided by T is going to be definition that you can use in order to measure the current or the flow of electrons. That we use it as what? That we are going to use it as a current. On another hand, we do have something we call it as V. Or voltage is a way that you can measure the energy that you have inside of your source itself. Or in another way, we know some kind of a formula, or we know something as W as energy. This is joule, right? We know it from physics. The amount of energy that you need to consider in order to move the Q number of charge, the one Q that we had over here, is something that we call as V, as voltage. Okay, this is the definition. The joule divided by coulomb is going to be your voltage. And finally, we do have the resistance itself. Resistance means that the amount or the number, or I can say that how much resistance or how much fighting is happening inside your material in order to fight against the movement of your electrons or the movement of your current. So these are important parts, not only about series circuits, but about the whole electrical circuit. And right now, and in the next slides, we are going to see some kind of connection between them, because obviously we just don't have them like this. Okay, we have the current, how we have the voltage. For example, how we are going to calculate them. Is there any way? So we do have the measurements for something, right? We're not going to just measure something a tick. We just measured it. Okay, that one. Duh. Let's see the next slide. So calculating the total resistance, before just talking about the everything we had, let's just see some kind of example. Let's see some steps. The very first step that in each circuit is that we have to find how much resistance we do have against the current. How we can find that? It was simple. As I just told you, the total resistance or total fighting is R1 plus R2 plus R3. And we know the unit measurement for resistance is ohms, right? 10 ohms plus 20 ohms plus 30 ohms is going to be 60 ohms. It means that either I can write down all of my resistors like this, or I can just simplify it into one as 60 ohms. So it means that resistors in series always are going to increase the total opposition to current. Against that, you're going to fight against your current. The more resistance you have, the more fighting you have, the less current you would face. What would R2 be if we added a 40 ohm resistor to this circuit? Obviously, it's not that hard. Imagine instead of just having 3 resistors, you're going to have the fourth one and your R4 is going to be 40. Add them up, add it with 40, add it with 60, you have 100 ohms. Simple as that, right? Calculating the total current, we do have a law that we call it as an Ohm's law. What is Ohm's law? Ohm's law would say that you do have a couple of things inside your circuit. It's current, voltage, and resistor. Why not try to find a way to connect those together? And we do have it as something like this. I total is the whole voltage that you have for your circuit divided by total resistance. I total is V divided by R. Or we can just kind of this one. There's a very famous triangle, V, I, R. If I would like to have the I itself, if I would like to find I, the only thing that I have to do is just put my thumb over here, hide it, and what I get, V divided by R. If I, instance, if I would like to have the R itself, I can just put my thumb over here, I do have V divided by I. Because you can have 3 different, some kind of equations out of it. I is V divided by I, and V equals R times I, okay? We do have these 3 important equations that we call it as Ohm's law. This way we can find the relationship between our voltage, our resistance, and the amount of current that we have. Imagine that I do have a question like this. I do have 12 volt as my source. I do have 10 ohms, I do have 20 ohms, I do have 30 ohms. In total, I do have 60 ohms. And the question is this: how much current is going to pass? How much current is going to pass inside this path? So I do have 12 volt divided by 60 is going to be 0.2 amp, or most of the time we show it with milliamp because it's not that big, 200 milliamp. Why? Because 0.2 times 10 to the power 3, each amp is going to be 1000 milliamp, is going to be 200 milliamp. So this constant flow, this 2.2 amp, is the exact amount of current that is going to flow through R1, R2, R3, the whole, some kind of the voltage sources, it doesn't matter. It's the same everywhere. One thing that we do have in order to measure the amount of current is something we call it as multimeter, or to be specific as ammeter. As you can see over here, ammeter is connected in series. It means that if we are trying to look from in close what is happening over here, I do have my current that goes through here. Then by connecting my ammeter using 2 wires, this is going to be positive side of ammeter and negative side. By the way, we do have a lab and I'm completely going to talk about it, how you can connect it, but just have it in your mind. I'm going to make a disconnection over here. Then I'm going to connect the positive side of my ampere or some kind of my ammeter there. The current goes through my ammeter. Then it gets out and goes through this point and then goes through the R2. It means that instead of just having a wire over here, I'm going to put my device, which is going to be the multimeter or the ammeter itself. By putting this one and by knowing the fact that the amount of resistor inside this guy, because obviously when we're talking about the total resistance, we have to consider all of the resistance we have in our path. The amount of resistor inside this guy is so low, it's something around 0. So it's completely negligible. I can ignore it. It's not important. Instead of just having the wire, I'm going to have this one in order to measure the current. This guy, again, is going to use a couple of formula inside of itself, use a couple of calculation by having some kind of devices, and then it's going to measure the amount of current that we have. As simple as that. So what would happen if we do have the voltages? As I just told you, the E total is going to be what? The voltage of 1 plus voltage of 2 plus voltage of 3. But here's the real section. Because I told you that resistors are actually something that's going to fight against the currents. By putting resistance one at a time in each part of this circuit, I'm going to absorb the voltage. You can see that I do have a 12 volt, and 12 volt is equals to voltage of first resistor plus second resistor plus the third resistor. But this voltage is not a good one. Why? Because it's absorbing the energy from my source. Imagine that I do have the 12 volts. At this point, I see 12. It means that if I don't have any of these guys, and if I do have my load directly connected to over here, this guy is going to fill the whole source. It is so juicy. But when I do have my first resistor on the side, instead of just having a 12 volts, I'm going to lose something over here. That losing is something that we call as voltage drop. At this point, instead of just having the whole or potential of this 12 volt, I'm going to have 12 minus something. That we call it as V1. V1 is the amount of voltage that first resistor is going to consume and is going to be subtracted from the 12 volt itself. Then I do have the R2. So voltage at this point is 12 subtracted by V1 by V2. Then I do have this point, which is 12 subtracted by V1 by V2 by V3, which is something we know as 0. Why 0? Because this V1 plus V2 plus V3, we know it was 12 volt, or it was the total voltage, right? That's why we do have this diagram. As you can see over here in this diagram, at the very beginning I had 12 volts. Then I had the voltage drop of 2 volts. Again, I will show you that how we can calculate it. Then I had the 4 volt voltage drop. Then I had the 6 voltage drop, and I reached to 0. From here to here, I have my whole 12 volt that was connected. But right now I'm losing something. So here's the real question. How we can find the voltage drop? And I'm going to answer you that. Have you guys, as you knew formula, or we know some formula, that in that specific thing, I total is going to be V divided by T, or V total divided by R total. What is V total? V total is your source. How much is that? That guy is 12 volts. How much is your RT? RT can be found by adding all of those 30, 20, and 10. Remember, we're still talking about a series circuit. 12 volt divided by how much? Divided by 60 is going to be what? Is going to be 0.2 amp, which the one that we already have. On another hand, we know from that specific triangle, like this V is going to be Ri. If I would like to find the voltage drop, the only thing that I have to do is put my thumb there. And what do I have? I do have R and I side by side, or I do have R multiplied by I. Cool. So the voltage cross R1 is going to be I total, because we know I total is equals I1, I2, I3. It's still talking about the series circuit. The current is constant, is the same all the time. Times R1. What was R1? R1 was the amount of resistor that you have for the first component. So 0.2 amp times 10 amp is going to be 2 volts. Where did you see the 2 volts? The voltage drop for the first one. Let's find the second one. IT is still the same, R2, 4 volts. We have 4 volts over here. Then we do have all of this calculation, 6 volts. 6. Now we learn two things. The voltage of each component, the summation of all of those voltages, is going to be the same as your voltage source, 12 volts. And also you can see by increasing the number of resistor, I do have more and more of voltage drop. And that completely makes sense, because if you assume that V is equals R times I, if you think that I is going to be I2 or something constant, by increasing the right side of this equation, I will increase the voltage itself. The more amount of resistors that you have, the more amount of voltage drop you would face. And we also some kind of prove the KVL that if you add all of them, you do have the 12 itself.